All right, hello and welcome to our webinar. This is the next one in the series. A month ago, we did a webinar on detection. Today, we're going to focus on optimization. So in the webinar from last month, the number one item that we got asked the most questions on was optimization. So we felt like we needed to come in, bring Kris in, and have a great session on this. Today, we're going to talk about how to outperform traditional timing plans. That's part of optimization. Optimization has a role in terms of congestion, has a role in terms of CO2 reduction, and has a role in safety. And we'll unpack all of those as we go through the session. So the first piece that I wanted to get into, and this is what goes on in my head when I think of outperforming traditional timing, I said, how do we know that we can do that? What is it about our system that gives us the confidence to say at an engineering level, yes, we believe that we can outperform your traditional timing? And it comes down to basically three separate areas. This is simplified into three areas. The first is simulation. So just like you will take a timing study and run a simulation in order to create your timing plan, we're going to do the same thing. So we're going to look at the volumes. We're going to run a simulation. We're starting from the same clean beginning point. So we've already got an apples to apples start. We're initiating. The next piece that's interesting to look at is we're not done when that's done. So it's not a static timing plan. Now we go into looking at real-time data. So once we have the initial parameters and we put that into the system, every second of the day, we're evaluating what the traffic looks like and we're making adjustments. So that gives us an edge over standard timing, traditional timing. And the other piece here is queue-based logic. And I'll show you what this looks like. But if you think of a normal zones that are in an approach, you've got stop bar, maybe advance, and you know if there is a car there or not. So you have a 1 or a 0, and that's pretty much the extent of it. If a car pulls too far forward and actually doesn't sit on that zone, it's a 0. And the same thing with advance. If you have a gap in there, somebody's checking their cell phone and somebody's already pulled ahead, that's a 0. It's going to tell the system that there are no cars there. Our system's different. So we're going to look at the entire queue. We're going to look at a video display coupled with radar with our fusion, and we're going to know how long that queue actually is, and we're going to be able to make decisions based off that. So let's look at traditional timing. If you're used to timing, you're used to this type of a model. You do your study, you run your model, your simulation, you draft a couple plans, you try them out. Maybe you make modifications. This could take a couple weeks to a couple months. This is a day in the life volume from our system. It's from one of our intersections. It's a standard Tuesday through Thursday profile. You have an AM peak, you have a PM peak, a little bit of lull in the middle around lunchtime, and then at nighttime, the traffic pretty much drops off. So in this case, we're estimating we need about 4 plans to cover Tuesday through Thursday, typical workplace traffic. But then we just did this, we're going to get complaints on the weekends, right? People are going to complain that traffic isn't set up for the weekend commute, so we need to add another plan. So if we want to make an improvement in the performance, we're going to make an additional plan. And that's the model here. So once you add in more and more conditions, like you add in summertime conditions, you add in event conditions, you get into that old pre-calculus integral type of mentality where if you want to get the area under the curve, now you need to split it into smaller and smaller segments. Same kind of thing happens here. If you want to get better performance and improve safety, you need more and more timing plans. So if you run that into infinity type of integral, you basically get a plan every second. And so how do you do that? That's where we have an advantage. So let's also look at the setup. If you look at an approach, typical approach coming up, you have stop bar and you have advance. Maybe you don't. That's going to tell you, hopefully, if a car is there or not. And then within that, you're going to have the logic of a maximum amount of time. If you hit that, you're going to turn it to yellow and cycle a phase. Or if you have a gap in the traffic, a gap between those cars of, let's say, 3 seconds, now you're going to cycle it as well. So you have a max out or a gap out. That's pretty much what you've got. And then you're going to refresh that plan about every 3 to 5 years. Also with that, as I mentioned before, if you've got a queue of cars, you don't necessarily know that's what you have. So in this case, if I showed you that the controller saw a 1 and a 0, and I asked how many cars that were there. You could really only know for sure that there's one car there, but there could be 10. There could be 20 cars. There could just be a gap at the advance and it not being picked up. So you're not really sure about the quality of the data. And the higher the quality of data, the higher the quality of the decisions. And so that's another advantage that we're going to have. So if you look at our system, camera view from a no traffic intersection, just looking at one of the approaches. Each of these yellow boxes indicates a car that's going less than 5 miles an hour. So we have all of these yellow boxes into our system. And next to that, we're counting how long it's been in a static or delay state. So if we've got this many vehicles, and I think when we counted this, it was something like 70 different items are being identified. We know who's turning left, who's turning right, who's looking to make a through movement. And with this information, we can compare it to the other approaches and figure out where we need to cycle. So that is a very big difference than looking at a 1 or a 0 along the approach. So side by side to compare the two, traditional timing, you have a study, a model, evaluation, your inputs, stop bar in advance. Maybe you have 1s and 0s coming out of those. Your logic is essentially max out or gap out, and you're refreshing that every 3 to 5 years. If you compare that to what optimization is doing, it's essentially refreshing every second with persistent traffic counts. So our system, when it gets installed, is a persistent traffic measuring system. That's what it does. It counts the cars and gives you that information, and it feeds that into the model. Then the model can make a micro simulation predicting the traffic for the next 2 minutes. So we don't need to predict the traffic for the next 2 years, just the next 2 minutes, and we're going to make adjustments on that to figure out what's going to give you the best performance. And we'll talk about what that performance means because it is heavily weighted by your policies if you're in an agency. Now, our inputs, as I showed you before, is a queue length, yes, but also platoon information. So if I'm at an intersection and downstream, I'm about to send 50 cars to the next intersection, I can send that information ahead. And that's another advantage that we're going to have and be able to coordinate and put that into the model. And all along the corridor, we have that level of visibility. So queue intelligence, platoon intelligence, corridor visibility. We have the max out and the gap out that we can run with both of those, but we also have delay waiting, which we can do. Not waiting like sitting and waiting. I'm waiting for something to happen, but like waits. So I mentioned all those yellow boxes are cars that are sitting in an idle state. So we count 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. We start adding counts and adding numbers, and those values then go into the model, and the model tries to minimize those numbers as low as possible. If I, instead of a 1, said, I want to weight it at 1.2, and maybe that's a pedestrian who makes a ped call, now I've got the ability to change the model based on your policy and do a delay weighting. So that's kind of what that means. And this is constantly being refreshed. That's how we get the confidence that we can go into an agency. We can go into an intersection in a corridor. We know we're going to run simulation and start from a known good point. We know we're going to have real-time data, which is a huge advantage. And we know with our queue-based and corridor-based logic that we're going to get information to make higher quality decisions. So all of those pieced together, and this is kind of what it looks like when you put it in the field.
See how NoTraffic Optimization handles the combined challenge of rush hour, light rail preemption, and pedestrian traffic. In this example, we see afternoon rush hour, where the highest volume moves from the top right of the screen to the lower left. On the left, we have traditional timing, and on the right, we have NoTraffic Optimization. Both are synced to a red signal. Light rail preemption forces movements that conflict with the train to red. In the optimized case, we have a light rail preemption, but we're quickly able to get traffic moving again. A second light rail preemption occurs in the optimized case. Traditional, pre-planned timing can struggle with repeated preemptions, and now we have had 2 light rail events in both cases. But the traffic flow with optimization adjusts and keeps rush hour traffic from backing up. With traditional timing, drivers are stopped for over 3 minutes without a green. At rush hour, this approach sees the heaviest volume and cannot clear the queue, resulting in a split failure. Drivers experiencing traditional timing continue to wait with queues backing up off screen. while NoTraffic's optimization keeps traffic flowing, managing rush hour, light rail preemptions, and pedestrians. NoTraffic adapts in real time, clearing queues and maintaining flow through repeated light rail preemptions and pedestrian activity. The difference is clear. It's time to rethink signal timing and get the technology you need to handle the unexpected.
Now, we've chosen this because it was complicated. You've got rush hour traffic trying to move through that area. You have a light rail preemption cross rush hour traffic flow. And you have pedestrians making calls in the area because it does see a decent amount of pedestrian activity with buses also integrated in there as well. Traditionally, very difficult situation to try and manage. When we have optimization looking at things every second, now you're able to get the kind of traffic flow that you see then. So a little bit about us. If you're unfamiliar with NoTraffic, let me just put this up for a second. We've been around about 10 years, growing very rapidly. So in a lot of agencies, we are the default technology for detection. A lot of agencies, we are the default technology detection plus optimization. And they will use us universally for that, but not in all cases. So we do sell detection as a standalone solution. We sell a number of applications on top of that. So if you're looking at near miss, if you're looking at Ped Protect or dilemma zones, we have application layers that are additive to what we do. And then today we're going to talk a little bit more in detail about optimization. Again, if you missed the webinar a month ago, please go check that one out. We cover the bases for what NoTraffic does. We are focused on Canada and the United States at this point in time. We are approved by all major DOTs. So we're pretty much being installed anywhere that you're located. And if you haven't installed this yet, we'd love to work with you. So helping us unwrap this a little bit, I wanted to cover what this could do for agencies. Kris is going to come in and join us and talk about how it's done and what the actual workflow looks like and dive in a little bit deeper. Kris, licensed PE and PTOE, he has over a decade of experience. You may know Kris if you've been working in traffic for a while, especially in the South with Florida and Puerto Rico districts. He was the leader at ITE in those areas. Coming out of Tampa, but he has a BS in civil engineering from the University of Arizona. And Kris, I'll hand it over to you.
Thanks, Mike, and pleasure to be with you all today. Talking about optimization. This is a product that I think has a lot of great potential in a lot of cities and a lot of different contexts. And we've been learning as we've been going since I've joined the company several years ago, and happy to be talking to you today and hopefully start the process of conversations moving forward. What I'm be going through is just a little bit more about how it works. Mike gave a great introduction of the impacts and the high level technical architecture. And I'm going to go a little bit more into the detail about what the system actually does. So again, if we think about signal timing, for those of you who came up through the civil engineering programs and maybe study traffic in your master's program and practitioners, we're all taught the same thing: cycle length, splits, offset, etc. A lot of that good technical knowledge is still within the NoTraffic system, but with new data and new technology, new sensing systems, we've been able to rethink, hey, what's really needed? Is a standard sequence needed all the time? Do we need a common cycle length? Those sorts of things we can start to question when we have new tools. And optimization is a new tool for traffic engineers and traffic professionals throughout the North American region. Again, when Mike talked about manual timing plans, when we talk about variability in traffic, we're always trying to set a new timing plan, go out in the field, try and make sure it works, provide the tweaks. I think we're able to do that a little bit quicker now with more tools. Improving safety. One of the things I think that's been a challenge for us in the traffic industry, and there are some great traffic professionals that have been pioneering work, but what the NoTraffic optimization tool allows a lot of us to do is start looking at, okay, maybe I don't want a major green band. Maybe I'm in a campus environment and the safe crossing of heads and bikes is really what I need. And when someone gets there, I need the system to be super responsive to serve that ped or that bike or the VRU a little bit more quickly so that it improves the compliance with the signal. It also allows the system to handle the unexpected. That's for those of us in the industry for a while. We've seen the evolution of traditional adaptive systems, and that was the starting point of the impetus. NoTraffic takes that to the next level, especially with some of the new architectures and new technologies that exist out today. So as Mike said, we talked a little bit about how the system works. It is decentralized, so this allows deployment in kind of a very flexible scale. What the system does is at the intersection, each system in the cabinet will predict the next 2 minutes what the optimal state is. Now, optimal is subjective, and that's something kind of in the configuration that happens when we set up the system. But the system will look 2 minutes in advance what the optimal state is. In the next second, we'll look another 2 seconds. The next second, so it's happening every second. It's looking forward about 120 seconds. 120 seconds or 2 minutes to see what the optimal sequence is. Do I hold it open the north and southbound lefts for additional 30 seconds? It's a long time. Or can I close it a little bit and get back to the main line, which could be east and west? It's constantly evaluating what's the optimal sequence to, again, first of all, reduce overall delay, but then adhere to certain policies, whether it be transit or VRU focused, coordination focused, queue focused, et cetera. It adapts to the patterns. It's not constrained by varying demand. It's set up by what my team does is we come out and work with the agencies and the stakeholders to set up policies. So whether that policy be hey, I don't want this ramp to back up onto the adjacent freeway, so we need to keep this ramp clear. We have oversaturation here. We want to balance two conflicting phases, or we're just looking for overall progression. That's a policy. Those are policies that we set up, and we help prioritize what those policies are during the setup process. So I talked about the decentralization component of the system. Next question is any traffic professional would say is, okay, that's great. What happens with the corridor? How do we have a green band? How do we make sure we have smooth flow through a corridor? And this is where the coordination of intersections using what we call platoon messaging between intersections occurs. So in this case, the upstream intersection called the downstream intersection. Hey, I have 50 cars coming, and the downstream intersection takes in information, determines what its policies are, and if its policies allow and for that platoon to go through, it will open, terminate phases sooner, or maybe extend the phase a little bit more to allow that smooth flow. And this is configurable by intersection, by approach. Makes it very flexible. Again, hitting on that point of this is a tool in the toolbox for the traffic professional. I touched a little bit on what the algorithm is. It is a delay weighting algorithm, and what it does is using kind of the newest technology. You've probably all heard of trajectory-based information, or getting that really rich data of all road users across an environment and trying to understand, okay, how many vehicles do I have done this phase in the right turn? How many buses? How many bikes? How many trucks? Where are they at in the queue? How long is the queue? All that information is fed into the NoTraffic Optimization algorithm. So that weights that information based on the policy we set up. Overall goal is to minimize delay, and that happens, and those simulations are every second, 1,000, 2,000 simulations every second. As we talked about, it is decentralized but allows to use the cloud for coordination. Some of the questions we get are where decisions made, what happens if the cloud goes down, what happens if your cell service goes down. Decision is local. So just like a traffic signal controller would, if you break that field of center communication, the controller takes over. It's similar concept to our system. It doesn't require the cloud system, but it's pretty robust, but it does. That's how we do coordination between intersections. And again, food management, this is something that I think that's very interesting. It's not just to say, okay, coordinated phase 2 here, phase 2 here. We can do coordination through a route. So if at intersection 1, I want coordination phase 2, then downstream, I have a heavy left turn, coordinate with phase 5. Then for phase 4, I remember my NEMA phasing, and then maybe phase 7, that's doable. It's flexible. It's not beholden to our traditional timing parameters that we've been working with. I'm going to go to the next slide. Again, as Mike said, it's constant monitoring and tracking. This is not done just only on system level, but also from my side. So my team is constantly looking at the system, looking at dashboards, working with customers to provide reports about what are the impacts, What are the trends? Hey, we're seeing some things here. Just wanted to bring this to your attention. Let's look at a different policy may help improve traffic here. Those are ongoing conversations, not only from a system side, but also from a monitoring side. And we use traditional traffic performance metrics, volume by approach, by phase, arrivals on green, delay, etc. Again, get into the algorithm. We just want to give you kind of the technical components as well, really hit this home. It's decentralized. Just hammer that point home just because it is a little bit different. Some systems have an on-prem server, or maybe they're moving to the cloud, and some of the decisions are made there. Really, every decision is made locally. It's just the sharing of information via the cell spectrum is needed. And we can set up a corridor however you want. So if you want this, we have 5 intersections, you want 1 and 2 to work together, but really intersection 3 is 2 miles away, the platoons would be dispersed. It's fine. We'll just work with you on connecting them, whatever makes sense for the traffic characteristics to provide the policy you're looking for. Again, hey, you say, hey, Kris, Mike, this is great, but what can I do in case something happens? If I get a complaint, let's say there's a work zone, I need, with my current system, I kind of have a little bit more control. This is something that the NoTraffic system has as well. And what it allows for is, let's say something were to happen, there's a closure or an event, and the policy that was set up was maybe restrictive. You have the ability in real time, you don't have to go through transition, don't have to upload and download a database. You can take control right away. Just if you were at an intersection with a police pickle or pigtail, you can hold a phase, force off a phase, change the parameters so that you can have a high traffic level of service for the everyday driver. And here's just some examples. You're always improving this, working with customers to see what are the controls that they want. This offers you the kind of the real-time type of operation. As you can see on the top level of the pane, it shows the demand. So it shows you how many vehicles does the system see per phase. What's the call? That's the call on the controller. The way the system works is it basically puts the controller rest in green and then places a phase call. Also shows you PED information. So there's a PED call, if there's a walk or don't walk or flashing don't walk, it shows that information. And then moving a step down into that decision item, it shows you what is the decision of the system is, hey, there's a minimum that I have to adhere to. Okay, I'm staying on the current phase because I'm at a minimum. And then it shows you the phase sequence it wants to go through. So in this case, it wants to serve east and west, and then move to westbound left and westbound through. Again, giving you more visibility about what is the system trying to do. If someone asks, hey, is this skipping phases? You have a clear indication of what is the system thinking so that you can make an intelligent assessment. And then underneath that's a control side. So you can see, hey, if I want to force off a phase, place a hold to hold a phase longer, want to flush something out, you have full control. And a lot of customers don't really need this, but let's say there's a work zone, they close something, let's say we're on traffic, we know no day is the same, and it just offers you the ability to control should things happen. So going through a timeline, what the system does is since it's so flexible, is we go through a process with you where we look at the corridor, we review it with you, we look at what your policies are, what you're trying to achieve, really a workshop format, run the simulation. So say, hey, based on this configuration, based on what you said, here's what you can expect. This is a good opportunity to say, hey, Kris and team, I thought we want a smooth flow, but let's see what will happen if we prioritize maybe a more equitable type of operation. Cool. Run a simulation, show you the results, and then we can pick and choose. And now you have a good understanding about what the system is going to do, how it's set up before anything gets put on the street. And I think that's a really good differentiator for NoTraffic, because traditional adaptive systems, or even just let's say you're doing a timing plan, first thing that happens is the phone rings, complaints start coming in. By trying to do a lot of that pre-work ahead of time, a lot of that preparation, nothing's going to replace in-field verification and tuning, but we can start with new tools, new simulations, new technologies, we can really try to reduce that friction when you're trying to make an improvement. We then turn the system on, work with you in the field, walk you through how the system's operating, go through a tuning phase where you're looking for 30 days really intensely about what's going on, and then go into the support side. When we talk about policies, this is something new, but I think you're starting to see it with other in the industry overall, is that you have something we want to do, and then help me figure out how to actually get there. That's what a policy is. It's the high level what you want to do, not how, of defining the high level objective and then having the system execute that objective. So here's some examples that some of our customers have used. We're always learning more, the more and more we deploy. So I see this list probably growing over the next 5 years. Try to think yourself, okay, hey, Kris, Mike, this is great. Why now? Help me understand where this would be impactful. I think one of the biggest things is we're always being asked to do more with less in the industry, and we're always trying to see how we can do more analysis, provide a higher impact, or be more responsive to our citizens. What this system allows you to do is have your cake and eat it too, because with the system comes the support, the service side, which is my team, and a lot of agencies have used us as an augmentation for their staff, where maybe they have 3 timing engineers, but they need 6, and we fill that gap with the technology. The other thing to think about is where maybe our complaints are coming from. There are several projects we have where the agency is really big on customer responsiveness, and being able to analyze, understand, and provide a solution within an afternoon is really important to them. So are there intersections or corridors that you'll need that higher level of service? That's a good sweet spot for NoTraffic. Also, one of the things we've seen, this is more tactile or more maybe in the weeds, is at terminals. So some diamonds, some agencies will have 2 cabinets on either side of the interchange. And that's great for kind of an implementation side. It's a cabinet on the west side, cabinet on the east side, and now you can, from a hardware perspective, it makes it simpler. Don't do overlaps. You have to run wire back and forth. The challenge is then how do you get those 2 coordinated? And traditionally, I've seen presentations where they've had 50 logic statements and then peer-to-peer communication and all these fallback mechanisms. Well, so our system accommodates that. We have many examples of that. So I think ramp terminals is a very interesting niche that we fit, and a lot of our customers have found success in. Another thing, just thinking maybe a little bit from a corridor perspective, what we've seen is that we've been able to improve the level of service even with an increasing volume. So we've just gone through a few projects where we've seen the volume actually increase from when we were off. So before the system was installed, we do data collection period, system was turned on, we showed the improvement, but then over time, we see the volume increase. And this happened multiple times. Even with that, we're able to see an improvement in the operation. So it allows you as the user to try and eke out as much capacity as possible before going to that expansion route, which was let's capital improvement and potentially go to bond and get counsel and plan and design and work zone, et cetera. So in traffic system, you put it up and then you can eke out the capacity. Not saying the system can solve physics. That metal is a solid. It still is and always will be, but it allows for that maximum efficiency before you're going to that next step of expansion. Mixed use corridors, traditional adaptive systems deployments have been commuting corridor where you need a large green band. That may be 10% of your signals, but what about the other 90% where it's mixed use? And especially with infill and land development, the interactions get more complex. So that's a good sweet spot where you're really trying to minimize delay, minimize queues. That's a really good sweet spot for the system. From a driving pattern, growing areas. We've heard from many customers that they're making major developments and they're always having to go back to this intersection or work with outside help to help them retime every 6 months, every year, because it seems like this never-ending exercise. That's the sweet spot for adaptive in general, just because it allows for driving habits, but our system is not constrained by periods or cycle lengths, offsets. splits, etc. So it allows a lot more flexibility. And then safety. This is something interesting that my team is really starting to analyze is time and time again, we see a reduction in red light runners. We have some assumptions about what that is. We can't say for sure, but it is a constant output. I'm not to say correlation is causation, but what we're finding is that red light runners have decreased with every project we've put out there. Why that is, we have some assumptions, but I think that is something we're exploring more to see what the safety outputs are. And then from an economics perspective, if you're looking at this from an intersection level, let's say you have a NoTraffic system and you're trying to pick, hey, where should I look? Really anything over 20,000. If it's a light intersection, there's only so much delay you can improve on. But the other thing is if you're going to retime it, let's say our traffic system goes in and we provide the same performance or similar performance. Even if you were to retime that once in the FHW recommended, I think it's still recommended 3 to 5 years, you've now recouped a good chunk of your costs just in that reduction of retiming effort alone. Let alone what we've seen the system do is actually improve performance. Then your return on investment. This is something we've discussed in talking with folks like public works directors and city managers and directors and elected officials. Just adds that sweetener of what the system is. Now give you a little bit about what the system, a little more technical depth about what the system is, a little bit more about how to actually start deciding which intersections or intersection is right for it. But just give you a few examples of what some of our customers have done. So Oklahoma City, Route 66, they're looking for, it's a pretty standard type of corridor where, hey, help us improve coordination. We get complaints on the side street, help us reduce those complaints on the side street because initial coordination is maybe having them wait too long. And what we're able to do is improve the coordination, reduce delay, reduce the side street delay, and then show the economic benefits. Just a disclaimer, the economic benefits it's a pretty standard calculation that's folks in the industry use. It's just using delay, volume, a value of time taken from Texas Transportation Institute's Urban Mobility Report, and using that for after delta volume done. So that's just a little bit about how the calculations are done. And then in any signal timing project, you have a benefit cost ratio. So what's the cost versus what's the benefit? Houston, Texas, this was a little bit different. What we had was their focus was more on event management coupled with normal peak management in a growing area near the hospital area in the city. One of the interesting things is we saw a major reduction in red light running. Any of you been to Houston? Sometimes driving around, nothing against Houston drivers, but it feels like a little bit like Mad Max driving around there sometimes. So red light running was a very important concept, a very important metric for them. And we were able to have a reduction about 42% there. And again, what we're seeing is that it does have an impact in event management. And that's something we're exploring more and more as the system gets more mature with the city. Lastly, just to give you, so those are two examples. We have many more, and you'll start to see more and more case studies throughout the year and throughout the years. We really try and evaluate every project and provide the results in a public format so we can see what the impacts are. And so the industry can see them as well. But just to give you a sense on the top of your screen, you'll see 3 projects we've done. I'm on the East Coast. This is more for the West Coast folks. Tucson, Arizona, nearly 50% delay reduction. And these are with corridors that had just been retimed in the last 3 years. Phoenix, again, like you saw in many major cities, safety is important. And what we're able to see is have a kind of a chocolate and peanut butter type of scenario where you're able to improve operations and improve safety. And this is using pretty robust data to prove that out. And then in kind of a mixed corridor concept where this was an interesting project where we didn't really vehicle like, okay, that's great, but it's a campus setting. We want students to have a more walkable community and really that complete streets type of setting to try and reduce pedestrian delay. With a better system and better operations, you're able to reduce head delay here. And on the bottom, you can see some from some other customers about some testimonials about the overall system. So as Mike mentioned, optimization is one application of the NoTraffic platform. Typically, folks user detection and then add applications in thereafter. Optimization being one, but our ISI application, near miss, et cetera. There's all sorts of applications. And then lastly, again, continuing to point, how do we know? It's important to really understand the fundamental differences and fundamental advancements that NoTraffic has been able to provide. One is the simulation results. With higher computing power, we can do a lot more in a digital environment. We can look at scenarios and scenario plan and that, hey, what if this left turn had 50% more volume? What would the impact be? What would it be like on a Saturday at 3 p.m. when a football game gets out versus PMP? The data is there. We just push a button and we show the results. Real-time updates, the system is able to be updated consistently and it's always updated. The data comes in, it's calculated and then move forward. And the last thing is hue-based logic. We're not limited by ones and zeros. Or for more advanced users, maybe you look at zone occupancy or zone speed. We don't have to infer any of that. We know there's this many vehicles here. They've been waiting this long. Here's the speed. Here's the type. With that data, there's a lot more power in it. That's just a little bit about the NoTraffic optimization system. And I just want to thank you for your time here today.
Yeah, that's fantastic. Real quick on this slide, just a summary of what we've talked about. If you look on the left side of the slide, that's kind of optimization. That's where those benefits have landed. In the center, detection. So that's the core of it all. And that's why we put it in the center. Reliable, accurate detection. So if you don't have that, you can't really run anything else. And that is really at the center of it all. If you look at traffic flow, it means reducing delay. If you reduce delay, cars are not on the road as long. You can put in those equations like Kris had mentioned and calculate your emission reductions. We also see significant reductions in red light running. And I want to just put some clarity around this. This is not because there's a big camera sitting up there staring at the drivers. That camera was there before because in our detection setup, it's the exact same physical presence. So when we say before and after, we're talking about our detection being deployed and the camera being up there looking at drivers seeing that there's a camera. So we don't think it's a response to a physical camera and they think it's a red light running camera, right? That's not what the data seems to indicate. So that's on the safety, maximizing existing infrastructure. This is something we hear consistently with optimization customers. So imagine you have a 2-lane road and you're thinking, should I add a 3-lane road? This is like putting in a 2.4 lane road. Obviously, that doesn't exist, but if you're getting 20% better traffic flow, conceptually, that's what you've done. You've added in 0.4 extra lanes in terms of volume that you can handle. And that's a big difference. So if you're moving the traffic through, if you're reducing the delay, it could also delay a multi-million-dollar project of adding in additional lanes and let you consider other options. So we'd highly recommend it if you're evaluating additional infrastructure, because that could be very expensive. On the right side, that's where we talk about the applications. If you're interested in those, see the previous webinar. Future-proofing your investment is a big deal. Things are changing very quickly nowadays. So getting something installed today that you can add on to in the future in terms of application, like we launched near miss in December or October of last year. So these things happen quick. We're going to add more applications before the end of the year. Just to give you an idea, we've got a number of them in queue. I won't say what they are. You can join us for another session and we'll dive into it. And then the last piece on the far right of the slide is proactive maintenance. So we have a 24/7, 365 days, fully staffed support team. We call it the NoTraffic Operations Center. They are not looking at your traffic flow. That is what agencies are best at. They are going to maintain your equipment. So think of this like an IT team for your equipment that's at the intersection, for your cloud, for your mobility OS, making sure everything's running in the background so that you can come to work and do your best job. And in addition to that, they are proactive. So if they see something going on and they can correct it over the air, they will do that. High winds, we have hurricanes. Kris knows this in Tampa. I'm in Jacksonville. We see hurricanes all the time. With hurricane force winds, you can see sensors drift slightly. Our team can go in and redraw those zones for you so you don't have to deploy a truck. You can deploy that truck to fix the tree limb that fell down in the middle of the road. More higher priority concerns. So our team can help with that as well. And that's one of the things they do in proactive service. Awesome. Thank you everyone for joining us today. It was a great session, a lot of great turnout. I love seeing the crowds here. And thank you, Kris, for presenting. Any final words for anyone?
Have a great rest of your day.
All right. Thank you, everyone.